Hey there, it's another one of these videos where I help you get ready for the test. This one's on Chapter 6. So Chapter 6, quadratic functions. What have we done so far? Okay, we started by graphing those parabolas. In order to do that, we needed the y-intercept. We had to find the axis of symmetry and the vertex. And once we had it graphed, we could find the x-intercept, also known as the roots. Okay. We could also look at the concavity, whether it's opening up or down, and look at the domain and range of the parabola. We also used factoring. All right, so we used factoring, or various factoring methods, in order to find the exact value of the roots. Okay, so using the zero product property, we did simple quadratics when a is equal to 1, and we used grouping when a was not 1. Okay, we also used the square root property, completing the square, and the quadratic formula. All right, so let's talk about graphing, the parts of the parabola. So here we have our general form at the bottom, f of x equals ax squared plus bx plus c, and in the graph we have a nice looking little yellow parabola. Okay, the first thing of note is the y-intercept, which is always 0, c. Okay, we can find the axis of symmetry by plugging into the formula x equals minus b over 2a. Remember, that's always going to be an equation. So when you write your axis of symmetry, write x equals and then whatever value it is. Okay. Once we know the axis of symmetry, we can plug in that value of x into our original function and find our vertex. The vertex is always the maximum or the minimum value. If my parabola opens up, then my vertex is the minimum, like in this case. If the parabola opened down, then my vertex would be the maximum. Okay. Once we have it graphed, sometimes we can identify the roots. That's where our parabola crosses the x-axis. So there are x-intercepts. Okay. We can then analyze the concavity. Like we talked about with maximum or minimum, if the parabola opens up, okay, its concavity is opening up. If it opens down, then that's the concavity opening down. And finally, domain and range. So for this particular parabola, our domain is all values of x, all real numbers. And our range has a minimum value, so the low end of that would be whatever the y value for that purple dot would be on our vertex. And the upper end of that would be infinity. So let's talk about the roots, because a lot of what we're doing is all about those roots. So there's basically 3 different things that can happen. Okay, we can have a parabola that crosses over that x-axis twice, and that gives us 2 roots. We can also have just one root. Okay, and that's when it crosses the x-axis only once. That means that our vertex would also be our root. And sometimes it can have 0 roots if it just never ever crosses the x-axis. Okay, so we have all these methods for finding our roots. Let's talk about those for a minute. Okay. The first one we talked about a little bit, it's when we just graph the parabola and we look to see where it crosses the x-axis. Okay? We can only use this sometimes because if our graph isn't perfectly exact, then we might get the wrong value. Okay? So this is one of the ones we're going to use sometimes. We can also sometimes use factoring. So if I factor the quadratic below, x squared plus 5x plus 4, I can find the 2 values that multiply to 4 and add to 5, so x plus 1, x plus 4, and then go ahead and solve those 2. But we'll get more into that later. Remember, that can only be used sometimes. And the square root property we can sometimes use too. So if a perfect square is set equal to a constant, like in the example below, x plus 5 squared equals 16, I can just take the square root of both sides and solve. So all the 3 of these that are on this screen, we can only use sometimes. The conditions have to be just right to use these. We also have 2 methods that always work. The first one is completing the square. So we're going to use this when we can't use any of those other easier methods. So if we look at the equation I have below, x squared plus 6x plus 4, can you think of two numbers that multiply to 4 and add to 6? Probably not, because I can't. So we'd have to use the completing the square method. Or we could use the other method that always works, the quadratic formula. So this one we use when other methods fail or are too tedious. That means they're really not fun to do. If we look at these two, the completing the square one works really well when our b, in this case 6, in the x squared plus 6x plus 4, if our b is an even number, that one tends to work to be relatively easy to do. And when it's not, it's a little harder. So we might want to go with the quadratic formula. All right, so those are our 5 methods for finding roots. Okay, zero product property. All right, so this is just saying if I have this trinomial set equal to 0 and I factor it into 2 binomials, I would get this. Okay, I could check that by doing monkey face or FOIL if I wanted to, but I'm pretty sure it's right. All right, so now what that means is that I can set if either one of these binomials is equal to 0, then this is a true statement. So that means I can break it up into this. X plus 2 equals 0, or x plus 5 equals 0. Okay, and then I just solve each one. So x is going to be equal to -2, or x is going to be equal to -5. If either one of those things is true, then this whole thing is equal to 0. All right, so let's briefly review factoring a simple quadratic. So here we go, x squared minus 13x plus 42 equals 0. Okay, we're going to look at it carefully. So it's a quadratic where our leading coefficient is 1. So this is going to be simple factoring. So I just need to find two numbers that multiply to positive 42 and add up to negative 13. I can go through all my factors, and I'm going to find that -7 and -6 are my two numbers. So I create two binomials using those two values. Okay, and just like we saw in the last slide, I can set each binomial equal to 0 and solve it. So my values would be 6 and 7. Those would be my solutions. Okay, we'll look carefully at this one. It's a little bit different. The leading coefficient is more than 1. That means I have to use grouping. So I can factor this, but I need to use grouping, which some of you, I'm sure, don't remember that well. Okay, so here's the process. We multiply the leading coefficient, A, by C. So we have 3 times 15. That gives us 45. Okay, so now we find two numbers that multiply to that 45 and add up to the coefficient of the middle term, -14. Okay, we find those two numbers, in this case -9 and -5, and we break up that -14 into those two. We bring down our 3x squared and our 15, and then we put those parentheses around it, and then from there it's just GCF. All right, this one's a little strange looking. Let's take a closer look. What do we see? Ooh, both sides are perfect squares. That's nice. So we're just going to use the square root property on this one. Okay, we're just going to take the square root of both sides. So we end up with this. X plus 7 equals plus or minus the square root of 3. Okay, we're using both roots of 9. All right, which we can break up into x plus 7 equals 3, or x plus 7 equals -3, and then solve each side. All right, we find out that x equals -4 or x equals -10. All right, completing the square. Now remember, completing the square can always be used. We can use this one with anything. All right, the one thing we look at this carefully, we see it can't be factored as a simple quadratic or simple trinomial. So we need to use something different. So it's either completing the square or the quadratic formula. So let's do it with completing the square. All right, so we're going to get rid of that 13. So we're going to add the opposite of that to both sides. So now we have this. Okay, we're going to take half of our middle term, b, and square it. So negative 4 squared gives us 16. We're going to add that to both sides. And now we have this. X squared minus 8x plus 16 equals 3. Okay. This left-hand side is a perfect square. Okay, so it would be x minus 4 squared equals 3. At this stage, you should always do a little check. Do a little monkey face on the x minus 4 squared to make sure that you come up with the original formula. All right, and then from there, we just use the square root property like we did on the previous slide. All right, finally, we get to the quadratic formula. So go ahead and start singing. And there it is. X equals, I won't bother. I won't kill you with my terrible voice. All right, so what are we going to do first with this thing? If you notice in the quadratic formula at the bottom, I have the b squared minus 4ac in a slightly different color. And we're going to talk about that in a second. So a, in this case, equals 1, b equals negative 8, and c equals 13. All right, we need those three values in order to use this formula. But there it is, the discriminant, b squared minus 4ac. We're going to talk about that first. All right, so let's move that up. And let's plug in. We know b equals negative 8 and c equals 13 and a equals 1, so let's plug those in. And we get this, which would turn into this, 64 minus 52. Okay, 64 minus 52 is 12, if I remember correctly. All right, so these are the four things that can happen. If the discriminant is a perfect square, we'd have two rational roots. Okay, here we don't have a perfect square, so it's not this one. Our discriminant is positive. We'd have two irrational roots. This is what we'd have. This would be our answer. All right, if the discriminant is 0, we'd have one rational root. Remember, that's when we'd have our vertex being an x-intercept. And the last thing that can happen is if the discriminant ends up being negative, we have complex roots. So that's when we have those imaginary numbers in there. Okay, and like I said before, in this case, our discriminant equals 12, so it would be the second one. We'd have a positive non-perfect square, so we're going to end up with two irrational roots. Now that means that our roots have square roots in them. So let's talk about actually solving to find out what those roots would be. We know that they're going to be two irrational roots, so let's find them. So here's our equation again, and here's our a, b, and c. Okay, and here's our formula. So let's go ahead and we'll plug all that stuff in, a, b, and c, everywhere it goes. And you should end up with something that looks like this. All right, I color-coded it a little bit so you could see where a, b, and c went. And now it's just a question of simplifying this thing. So we have to go ahead and we have to simplify it whenever we can. Let's do all that stuff under the radical. And we have the two negatives out front. We'll combine that. And we'd end up with this. Okay, now it's very easy to think that you're done at this point, but we have to be careful. Okay, that square root of 12 has a perfect square in it, so we need to simplify that like we did back in chapter 5. So let's go ahead and do that. Like 12 is 4 times 3, so it would turn into 2 times the square root of 3. All right, and even here I'm not quite done. So if I look carefully, 8 is divisible by 2. The coefficient of the radical term, 2 square root of 3, has a coefficient of 2, and the denominator is 2. So if I factor out a 2 on the top, I'll get this. Okay, and now the 2 outside the parentheses and the 2 in the denominator will cancel each other out, and we'll end up with this. Okay, now if you go back to the problem that we did on completing the square, it was the exact same problem as this one. So if you try to finish that problem, you should get this answer if you did it right. Okay, so what if we have the roots and we want to find our function from the roots? Okay, this is just going backwards from all the stuff we've been doing so far. We've been finding the roots. This way we have the roots and we're trying to find our original function. So here's the 2 points on my graph, right? I have negative 4, 0, and 3, 0. Okay. So I'm going to plug these numbers, these x values, into this. I have x minus and then whatever one of them is, and then x minus whatever the other one is. So I'm going to go ahead and plug those in, and it looks like this. X minus a negative 4 times x minus 3. Okay? So I'm going to go ahead and subtract that negative, and I end up with x plus 4, x minus 3. Now I'm just going to go ahead and monkey face this thing, and I'll end up with f of x equals x squared plus x minus 12. Okay? If I wanted to check that, I could go ahead and factor it again to see if I get the same roots that I started with. And that's it. If you can do all the stuff that's been in this slideshow, you're in really great shape for the test. Make sure you do a really quality study buddy. This is the last grade of the second quarter, so we want to make sure that it's one great grade to put in there and boost that overall quarter grade and semester grade. All right? Take care, guys. I'll see you tomorrow.